Which of the following ligands can show linkage isomerism? Which of the following ligands can show linkage isomerism? Linkage isomerism is possible only for the complexes containing ambidentate ligands. So what are the ambidentate ligands? Yes, NCS minus, NO2 minus and Cl minus. In these three options, all these three ligands are acted as ambidentate ligand. A ligand which is containing two donating sites. S is the donating site and also N. O is the donating site and also N. C is the donating site and also N. So the complexes which are containing ambidentate ligands can show linkage isomerism. Question number 2. Which type of isomerism is observed in the following complexes? Suppose ionization. Ionization isomerism is verified. In these complexes, which one is a ionization isomers? Let's look at this ionization isomerism. Complexes compound having the same molecular formula, but ions are different in solution. So in these all complexes, which one taken as ionization? Yes, in the last complex, which is dissolved in water, it gives bromide ion. When dissolved in water, it gives sulfate ion. Complex compound having the same molecular formula, but nature of ions is different. That belongs to ionization. Therefore, first one, answer D. And the second one, linkage. We already discussed linkage means ambidentate ligands are involved. That is called linkage isomerism. So for this linkage, the answer is NO2 ONO. That is third one. Coordination. Complex compound having the same molecular formula, but coordination pair changes. That complex are called coordination isomers. Let's look at this. Second complex, chromium, it is a cationic complex, cobalt is a anionic complex. It is a cationic and anionic. But in the same formula, here cobalt is a cationic, chromium is a anionic. Therefore, same coordination pair changes that are called coordination isomers. Hydrate, same molecular formula but different hydrate, inside and outside water molecule are different, that are called hydrate isomers. So therefore these are the answers. Yes. Question number 3. What type of isomerism is observed between these two complexes? Yes, look at these complexes. Both having the same molecular formula, but the difference is inside and outside water molecule is different. Therefore, this is called hydrate isomerism. If hydrate isomerism is not given the option, then it is solvate isomerism. That is the answer for this question. Question number 4. Question number 4. Yes, in these complexes, which complex geometrical isomers exhibit, and find the number of geometrical isomers. Yes, in this complex, the first complex, this one, MA4B2 type, square planar complex, MA4B2 type. This exhibits 2 geometrical isomers. This is MA2B2. This complex also exhibits 2 geometrical isomers. But the last compound, AA, this type of complexes not exhibit any isomerism. So not exhibit geometrical isomers. So therefore, number of geometrical isomers possible in the first complex is 2, second complex is 2, and the last complex 0. Question number 5. Which of the following compound complex exhibit optical activity? That means to exhibit optical isomerism. That is, which is optically active. Yes, look at these all options. In one option, cis-diamine dicarbonate of cobalt 3 is a type Ma2AA twice minus. This complex exhibits optical isomerism, but very important, even though this type, if it is a trans, it not exhibit isomerism. Cis MAA twice A2 minus, this complex only exhibit optical isomerism in cis form. Trans form do not exhibit. Question number 6. Identify the geometrical isomers of the following. Let's look at these options. In the question number 6, look at these options. first complex is in trans form, whereas the second complex and the fourth complex both are in chlorine atoms are in cis position. So therefore for first complex 2 and 4 both are geometrical isomers for second complex. Question number 7. By observing the following complexes, the two complexes are exhibit which isomerism. Yes, look at the two diagrams in the given options, in which chlorine atoms and a trialkyl phosphorus atom are in transposition to each other. In one case, chlorine atoms are in the same side and a trialkyl phosphine in the same side. That is this form. In another case, chlorine and trialkyl phosphine are in the opposite side. Therefore, that exhibit geometrical isomerism. Question number 8. The complex is type given CuNH3 taken 4 times plus 2, PtCl4 plus 2. In this type of complex, possible number of isomers. How many possible isomers are there? Yes. Me4, this is the type Me4, this is the type NB4. Okay. If this is a positive charge, compulsory negative charge. If it is a positive charge, negative charge. This is the type Ma2B2. To get adjusted plus 2, this complex is 0. To get adjusted plus 2, this complex is 0. Therefore, both 0 complexes are not possible. Therefore, this type is not possible. Yes, another possible? Yes, Ma4, Ma3B, MAB3, NBA3, and the next one MB4 and NA4. The total, including this complex, how many possible isomers for this complex type? Yes, the answer is 4. 4 isomers are possible. Question number 9. Among the following complexes, which show optical isomerism? Yes, optical isomerism is observed in the complex cis MAA twice A2. That means it is a bidentate line. Take twice 2. A2. Cis complex of this complex type exhibit isomerism. Question number 10. Which of the following statement is incorrect? Which of the following statement is correct? Which of the following statement is correct? Yes. Geometrical isomerism is not observed. Geometrical isomerism is not observed with coordination number 4 in the tetrahedral complexes. Coordination number 4 sphere planar complexes is possible, but in tetrahedral complexes geometrical isomerism is not observed. Question number 11. Question number 11. Stereo isomerism, optical isomerism. COAEN taken thrice plus 3 complexes. How many optically active forms are possible? Yes, there are 2 optically active forms are possible, that is dextro and levo for this type of complex. MAA taken thrice plus 3 type of complexes. Question number 12. Of the following configuration, which are taken as a optical isomers? Let's look at these options. These 4 options are there. In these 4 options, we observe second option and fourth option that are look like a mirror images to each other. So if 2 compounds are mirror images to each other but not superimposable, that compounds are called dextro and levo isomers. Therefore, optical isomers based on the diagram mirror images to each other, that is second and fourth. Second and fourth are optical isomers. Question number 13. Which of the following complexes have the maximum number of isomers? The complexes of the type COEN twice Cl2 plus, that is the type MAA twice B2. This type of complexes exhibit 3 isomers. So therefore this is the maximum isomer. Question number 14. Which of the following pair of complexes? Which of the following pair of complexes do not show optical isomerism. Yes, look at these options. In one of the option, this is the molecule PTEnCl2 and NiCl2Br2. In these two complexes do not show optical isomerism. So there are some conditions are there. Which complexes do not show optical isomerism? These are the type MAA-B2 and Ma2B2 type of complexes do not show optical isomerism. Question number 15. In which of the following complexes which is incorrect statement? Incorrect. Let's look at this one of the option PTEn twice plus 2 and COEn thrice plus 3. Both complexes exhibit optical isomerism. That is not statement. Both complexes do not exhibit optical isomerism. This complex exhibit optical isomerism, but this complex do not exhibit optical isomerism. But the given statement is both complexes exhibit optical isomerism. Therefore, the statement is wrong.